chart that looks like this, where we are comparing numbers and looking at their place values and how much value each digit holds. And what we're going to do today is we're going to look at comparing numbers, and without that chart, but we're going to use just some boxes to help us keep things lined up so that we can compare numbers that are in different place values. When we compare numbers that are in different place values, remember they need to be the same digit, and we're just comparing their value from one place to the next. So, for example, if I were comparing the number 60 and 600, then what I'm really looking for is I'm saying that this 6 to this 6 is one jump. And we already discussed that every jump that we take in our place value chart is 10 times bigger or smaller depending on the direction that you're moving. So because it's just one jump, this 6 is 10 times bigger than this 6 because we only made one jump. So 600 is 10 times bigger than 60. We can also say that 60 is 10 times smaller, or 60 is 1/10 of 600. So we could write that it's 1/10 of, because it's 10 times smaller. So if we use that fraction, that tells us it's smaller. If we come over here to this one and we look at the number 5 and 5,000, again, I'm comparing the digits that are the same. So I'm comparing the 5s, and we can see that we have 1 shift, 2 shifts, 3 shifts. Each shift tells me it's 10 times greater, or we add in a 0. So in this case, I need to have 3 shifts, means 3 zeros. So each one of these represents one of those jumps, letting me know that 5,000 is 1,000 times bigger than 5, or 5 is 1,000 times smaller than 5,000. So we can say 5 is 1,000 times bigger. Oops, 5,000, sorry. Or we can say 5 is 1/1000th of 5,000. It's 1,000 times smaller. So again, we're just comparing the digits that are the same, and we're seeing how many shifts took place. If we compared 40 and 4,000, again, I'm comparing the 4s because they're the same digit, and I'm going to look to see how many jumps are they away from each other. And I have 1 jump, 2 jumps. So they are 2 jumps away, meaning I need 2 zeros. That tells me that 4,000 is 100 times bigger than 40. I can also say 40, I can say 100 times smaller, or I can say it is 1/100th of 4,000. Let's do 3 and 300. So again, I need to see how many shifts take place. There's 1, 2, and those 2 shifts tell me I need 2 zeros, making it 100 times bigger or smaller. So 300 is 100 times bigger than 3, and 3 is 1/100th of, so it's 100 times smaller. And you could write 3 is 100 times smaller than 300, and that would still be acceptable. But again, the number of shifts tell me the number of zeros that need to take place. So if I did 50,000 and 50, the shifting still takes, it's still the same. So it's 1, 2, 3. There are 3 shifts of the 5, which means I need 3 zeros, and I know that 50 is 1,000 times smaller than 50,000, or it's 1/1000th of. I know that 50,000 is 1,000 times bigger than 50. Oops. And again, I could also write 50 is 1/1000th of 50,000. We can write these in a ton of different ways. We just need to make sure that we understand that the 3 shifts in place value means it's 1,000 times bigger or smaller. If you shift 4 times, then you would need 4 zeros, making it 10,000 times bigger. So for every shift, that's how many zeros there are. If you shift once, then it's 10 times bigger, which is 1 0. If you shift twice, then it's 100 times bigger, giving you 2 zeros. All right. There are a few practice problems on the next slide that you can work through and check your answers with the video to make sure that you understand the comparison of the same digits in the place value chart.